Okay, today we're going to be discussing the quadratic formula and the discriminant. So here are our content standards, and our mathematical practice is 8, what we're going to be using when we do our assignment. Previously, you've solved equations by completing the square. Now you're going to solve quadratic equations by using the quadratic formula, and then you're going to use the discriminant to determine the number and type of roots of a quadratic equation. New vocabulary, quadratic formula, and discriminant. Now you have found solutions of some quadratic equations by graphing, by factoring, and by using the square root property. There is also a formula that can be used to solve any quadratic equation. This formula can be derived by solving the standard form of a quadratic equation. The formula is called the quadratic formula. This you need to put to memory. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Even though factoring may be an easier method to solve some of the equations, the quadratic formula can be used to solve any quadratic equation. That is so important, let me say that again. The quadratic formula can be used to solve any quadratic equation. So let's look at an example of using the quadratic formula when we have two rational roots. So first of all, we're going to put the equation in the form ax squared plus bx plus c is equal to 0. Then we're simply going to figure out what a, b, and c is and then substitute it into the quadratic formula. So substituting in the opposite of negative 8 plus or minus the square root, and this is b, negative 8 squared minus 4 times a times c all over 2 times a. And then just simplify by doing the math. The square root of 196 is 14. So x is equal to 8 plus 14 divided by 2, or x minus 14 divided by 2. So x is either equal to 11 or negative 3. So the solutions are 11 and negative 3. So time for you to check your progress. So I hope you wrote down that quadratic formula before in your notes. You can use that to substitute in. So pause the video for a moment, then come back and find your answer. 2 and negative 15. So if you didn't get that, make sure that when we do our summary, go over our class summary, that you ask how to solve this problem. When the value of the radicand in the quadratic formula is 0, the quadratic equation has exactly one rational root. So what does this look like? First of all, we need to identify a, b, and c, substitute into the quadratic formula, and then simplify. Let me go back just for a moment. Notice that under the radical is a 0. So the radicand is 0. So x is 34 over 2 or 17. So that only has one rational root, one solution. If you were to graph this function, you would see that it crosses the x in only one spot. So it has one 0. It has one root. It has one solution. Time to check your progress. So pause the video for a moment, substitute in the quadratic formula, and come back and check your answer. All right, you got 11. So if you had a problem with that one, make sure you check with me tomorrow. Now you can express irrational roots exactly by writing them in radical form. So we're going to, again, substitute into the quadratic formula. And we end up with the square root of 28. Notice that. So we can simplify the square root of 28. It's 4 times 7. So the square root of 4 is 2. So 6 minus 2, square root of 7 divided by 2, or 6 plus 2, square root of 7 over 2. So we can divide the 6 by 2 and the 2 by 2. So 3 plus square root of 7 and 3 minus the square root of 7. We can approximate the solutions by finding out what the square root of 7 is by putting it in your calculator, and then adding 3 to it or subtracting it from 3. Notice that we have 2 zeros. They're approximated at 0.4 and 5.6. Time to check your progress. So did you get 5 plus or minus the square root of 13 over 2? If so, excellent job. Now when using the quadratic formula, if the value of the radicand is a negative value, the solutions will be complex. Remember the number I, imaginary numbers? Complex solutions always appear in conjugate pairs. So now we're going to look at complex roots. Again, we're going to substitute into the quadratic formula. Because we have the square root of a negative number, it's 4i. So 3 plus or minus 2i. So the solutions are 3 plus 2i and 3 minus 2i. Notice it never crosses the x, but we do have a root. It can show you that the solutions are complex, but it cannot help you find them. Sorry about that. Okay, we can check our answer by substituting back into the original equation. And we get that both sides are equal. Very good. Time to check your progress. So pause the video for a moment, work this problem, then come back and check your answer. Did you get 2 plus or minus I? Very good. Okay, now let's talk a little bit about the discriminant. In the previous examples, we have looked at the relationship between the value of the expression under the radical and the roots of the quadratic equation. Now the expression b squared minus 4ac, that's underneath the radical, you remember that part? We call that the discriminant. The value of the discriminant can be used to determine the number and the type of roots of a quadratic equation. The table in this key concept summarizes the possible type of roots. So if b squared minus 4ac is greater than 1, then it's going to have 2 real rational roots. I'm sorry, greater than 0, excuse me. And that's also if it's a perfect square. If it's greater than 0 and it's not a perfect square, 2 real irrational roots. If it is equal to 0, you will have 1 real rational root. And if it's less than 0, if it's a negative number under that radical, 2 complex roots. So you might want to put this in your notes so we can use it. Okay, now let's describe the type of roots. We need to find the value of the discriminant for this quadratic, then describe the number and type of roots for the equation. Okay, so we figure out what a, b, and c are. Then we just simply put in for the discriminant b squared minus 4ac. We're not doing the whole thing. We're just wanting to know the number and the type of roots. So 3 squared minus 4ac, we're going to end up with a negative number. So the discriminant is negative, so there are 2 complex roots. Look at another one. A is 1, B is negative 11, C is 10. So we end up with 81. There are 2 rational roots because the square root of 81, that's a perfect square. So 2 rational roots. Time to check your progress. So find out what the value is of the discriminant and then tell me what the number and the type of roots are for this equation. Oh, got a 0. So there is 1 rational root for that one. Let's try again. Oh, negative number, a negative 24. So there are 2 complex roots. Now you've studied a variety of methods for solving quadratic equations. This table simply summarizes these methods. So why don't you pause and read through this table, make some notes so that you are putting together the concepts that you've been learning in this entire unit. Okay, you're ready to begin the assignment.